experiment with videoing lectures may prove profitable here in a little bit. I found out today or maybe yesterday that it's becoming very, very likely that I'm going to spend 2 weeks in Mexico, probably in March. I wish I could say I was going to the Mayan Riviera, but instead I'll be going to a package facility somewhere in the bowels of Mexico City for 2 months or 2 weeks. So I don't know how that's going to affect our lecture schedule. I haven't talked to Rob or Seth about it yet, but I may tape a lecture and deliver at least 1 week that way. Okay, so be prepared for that. Also, as I mentioned before, I think I may send you an email. By the way, I sent an email that should have gone to everybody in this class. Did anybody not get my email? Okay, check if you would. I sent it last night. Check if you would to make sure you got that email. I know there was somebody who I couldn't send the email to because they didn't appear to have an email address. Jones. Who's Jones?
You sent it to me. You just sent it to my maiden name, which what I had in 2008 when I sent it before.
Oh.
So I did get it.
Okay, so you're probably down my list twice then. Okay, yeah. Okay, cool. As long as you got it. Marvelous. Cool. Yeah, and there's a few clarifications about the campus pad number 3 assignment as well. I just simplified the questions for you, made a little bit more straightforward. Okay, so that should help as well. We haven't been in the computer lab very much. The good Lord in His wisdom has decided to send the snow on Thursdays, it seems. However, in mercy, He has decided to send it on Wednesday this week. It's becoming something of a weekly event. I was on my roof, what was it, Sunday? Yeah, I was on the roof of my garage Sunday doing something I've never done before in my life, which is shovel snow off of a roof. But it was building up so much I was starting to get a little bit worried. And we see the snow sort of inside the window here is piling up quite dramatically. But as far as I know, unless tomorrow's storm turns into a blizzard that lasts for days and days, we should be in the classroom, not the classroom, in the computer lab on Thursday to catch up a little bit on what we're doing in Excel. I also noticed looking at the schedule that the first case is coming up, and I haven't given you guys that case yet. So here within a week or so, I'll give you that case, give you a chance to look at it. We'll talk about the questions that we're going to deal with on that. That first case was Oracle confronts open source. Okay, we're going to cover a bit about the value chain. We're going to talk a little bit tonight about information systems that support business activity. We'll talk a little bit about the strategic fit of IT to the organization, and we will talk probably very briefly about enterprise risk management. The value chain is a model that describes business as a sequential chain of activities, each of which adds value to the goods or services produced. That's my simplified description of what came out of the textbook. There's different ways of looking at it, but basically it's the idea that value is added step by step to a product in a company. Each stage of the chain is either a support activity or a primary activity. I work in finance and accounting for UPS. Do you think that's a support activity or a primary activity? It's a support activity. Part of the reason my department's being shipped off to Mexico. The primary activity of UPS is what? Shipping. Picking stuff up from point A and taking it to point B. And the beautiful thing about that primary activity is those are jobs that cannot be shipped off to Mexico. Such is life. Interestingly enough, the value chain is another Michael Porter invention. They don't make a big deal of it in the text, but the same guy that brought us 5 forces analysis and that kind of strategy also came up with the value chain. This particular diagram of the organizational value chain, inbound logistics, operations, outbound logistics, marketing and sales, and service, is the portion of the value chain. Somebody need in? Did we lock some of it? Sorry about that. portion of the value chain that relates to primary activities of the company. And it's usually laid out in this order, and more or less this is a chronological order, if you will. We start out with inbound logistics. Operations produces things. Outbound logistics gets it from the end of the assembly line to the customer. Marketing and sales drives demand. And pretty much every service today or product requires some sort of after-the-sales service, whether it be repair or something like that. Now, usually though, this is a little bit more. This is the more normal depiction of the value chain. Okay. No pictures per se in this particular. Everything that we saw in that earlier shot is here, and there is a diagram similar to this in the textbook. This is out of Wikimedia Commons, brought to you by some guy named Dinesh Pratap Singh. Excellent job of diagramming this. But usually, sometimes you will see the value chain. It's pretty much always depicted sort of like in this arrow format. Sometimes you'll have the bars across the top rather than the sections. They'll flip it. But the basic idea is the same. So we have our primary activities here. We have our support activities up across the top. And the reason it is depicted this way is usually because your primary activities are more or less sequential in the way they are pursued, whereas your support activities more or less affect every section of the primary activity. So they usually depict it as bars across the top. The better these segments of your business operate together, the greater your degree of margin when you bring the product to market. So primary activities related directly to the production and distribution of the product and service. We've given you already the examples: inbound logistics, operations, outbound marketing, sales, and service. Support activities are value chain activities that support the primary activities. And sometimes these are viewed as necessary evils. In a lot of companies, and to be honest, I'm experiencing this now. In a lot of companies, what companies do best, or what their main product is mainly here in operations. Okay. These other events are more or less related to whatever is the core of the business. Okay? And the support activities are often activities that in the modern enterprise, a lot of effort is made to either outsource or have somebody else do the work, for whom these are back office activities. And quite often in today's world, what's going on is you'll go to a company that specializes in these sort of activities and try to outsource or offshore those activities to those companies. That's actually basically what's going on in my facility right now. There is a company out of, I believe, Guatemala. The name of the company is Genpack. And a lot of our administrative, basically firm infrastructure for the most part, in my facility, is being outsourced to Genpack. Okay? For Genpack, what they specialize in is taking on administrative tasks from other organizations. So in a sense, for Genpack, the firm infrastructure is actually their operations. Okay? And so they're perhaps better able to do it in a cost-effective manner. So the value chain is the sum of the primary and support activities working together to create business value. It is another way to view the organization as a system. It's also a useful tool for defining an organization's core competencies and the activities it can pursue to gain a sustained competitive advantage. Now, in terms of IT, obviously there's every section, if you will, of the value chain is susceptible to automation, information, and transformation. They provide us here a list of information systems that support support business activities, functional information systems, workflow management, transaction processing, management information, document management, knowledge management, decision support systems, supply chain management, and ERP. Okay? And in some sense, although each of these are independent forms of IT in an organization, in some respects, what this list proves is that if a system has a screen and a keyboard, you can give it a three-letter acronym. Excuse me. Basically, what this list sort of demonstrates is that virtually every part of the enterprise can be improved with IT. Now, the functional information system, they refer to here as an FIS. FIS focuses on departmental activities to improve efficiency and effectiveness. Accounting systems, marketing systems, human resource systems, financial systems, manufacturing systems. And once again, if you have a department, in other words, a function, and you can build an IT system to support it, then you name it after your department. Okay, so once again, this slide is not outrageously informative, but it does show the breadth and use of IT in the business sector. Now, several of these different subsystems of tools that they list are worth mention by themselves. One of them is what they call a workflow management system, or a WMS. A workflow comprises all the parts of a business process: the steps, the resources, the input and output data, the tools. And a WMS focuses on a business process from the beginning to the end. Now, for the most part, WMSs are a planning tool, okay? They allow you to define the steps and relationships within tasks, and they're often used to flowchart processes. Now, at a higher level, once the process is built, it is possible to have a WMS which actually keeps track of the flow of work going through the system. At work right now, because we're in the process of moving my department to Mexico, one of the things I'm being asked to do is to basically chart all of the tasks. I have a bunch of things that I do, and I'm the only person that does them, and in some respects, I'm the only person who knows how to do them. I've got 7 people on my team. 2 are very, very specialized, and really nobody knows what they do but them. And then I have about 3 or 4 others whose jobs are all different, but they're all kind of related. They're more or less the same. So they came to me the other day and they said, "Do you have Oracle Tutor on your PC?" To which I replied, "What is Oracle Tutor?" And when they describe the process, when they describe what Oracle Tutor does, it seems to me that it is basically a workflow management system. Basically what it is, it's a layer that sits on top of Microsoft Office. As you define different types of activities, their sequence and the nature of the activity, it builds a flowchart model out of what you have told it. So over the next couple of weeks, what I will be doing is I will be trying to take this piece of software and try to chart the flow of work through my department. So if I'm so unfortunate to wind up stuck going to Mexico to help roll this out, I'll have a big picture, maybe even a little picture, workflow model that I can give to our Mexican colleagues. So in a workflow management system, each step requires and generates information and documentation. And we'll see in a moment that in some systems, the documents are so important that they become the core of a system and really redefine the whole system. So transaction processing systems, TPS. TPS brings together the common components of IT, must control the flow of both the activities and data involved in the transaction. It must incorporate the logic for controlling and enabling transactions, as well as having built into it the business rules of the organization, and it must include, or it really should include, necessary error handling logic. Have you ever heard of error trapping? If you ever do any programming, error trapping is one of the most necessary parts of programming, but it's also the most boring. You know what error handling logic or error trapping is is it's anticipating what the user is going to do wrong, and how the system is going to respond to that in such a way to put them back on the straight and narrow path. And one of the problems with a lot of transactional processing systems comes down to insufficient error handling. If you don't have sufficient error handling, you can get really, really bad results and not really know why. Some years ago, I built a system that, actually I built it inside of Microsoft Excel and using Visual Basic for applications. And it basically tracked the performance of call center employees in a center. I think at the time we had something like 300 people in the call center. It tracked their metrics, lets you draw graphs of their progress, that kind of thing. Emailed weekly statistics on performance out to representatives. And I had one of my colleagues, she would come to my desk and say, "It's broken, it doesn't work." And I'd say, "Elsie, everybody else is using it, it's fine, what's the problem?" She said, "It doesn't work." Okay, so I go to her desk and I'd say, "Show me exactly what you're doing." Okay, and she would proceed to show me exactly what she did. And some people don't like computers and computers don't like them. And this particular person would always find a way that I had not anticipated. They would do something with the program that I had never thought that anyone would try to do. And yeah, it didn't work when they did everything the wrong way. So I'd have to go back, I'd have to explain to them how to do it and whatnot. And then if necessary, I'd have to go back and I'd have to put in some checks and balances and some barriers to keep them from accidentally doing things the wrong way. Now, a fair bit of time is given in the textbook to discussing transactional processing systems. The smallest chunks of work done in a business process are usually done through a TPS. We can also say that usually most TPS systems are used in frontline applications. Whatever the company is about, usually where the company touches the customer, there's usually a transaction processing system involved. Now, a transaction is a unit of work that has the following characteristics. We mentioned this in the book. Atomicity, at least I think that's how you say it. It's a tongue twister. Good Scrabble word, that. Transactions declare a beginning and an end. If a process wanders off before it's clearly finished, the partial data is ignored. This is sometimes referred to as all or nothing. Now, when we talk about this may seem a little bit esoteric, okay? But when we're talking about transactional processing systems, we're pretty much always talking about systems that have a database at their back end, okay? So these define the rules under which databases deal with information, okay? And one of the first rules, if you will, is that if a transaction doesn't end properly, okay, if it never actually appears to end, the system will reject all of the information, okay, to keep the system from being corrupted. Consistency, the data fits into the system in such a way that it's clear that the data isn't garbage, okay? So the system will have checks and balances in place to make sure that takes place. Isolation, transactions have good manners, if you will. One finishes speaking before another one starts. Most TPS systems are on networks that involve hundreds or thousands of users, all accessing the same data or records. And databases have to be built in such a way that one user can't be manipulating or changing the data while another user is accessing that data. So basically what isolation is all about is that when a user on a transactional processing system goes in and goes into a user's profile, starts dealing with somebody's phone bill or something like that, the system locks out any other users from accessing and changing that same data at the same time. Once the transaction is completed, Once you've made your payment on your phone bill, or an error has been corrected on your phone bill, or something like that, the change is complete, then the locks are taken off, so that if something else needs to change from another direction, that can happen. Durability. Once a transaction is reported as done, a system's crash can't lose it. So another way of saying this is that a transactional processing system will not tell you that a transaction is completed until after it has written it to some sort of a log. And interestingly enough, when I worked at the UPS call center, we were using systems that booked pickups. I worked a lot in a department that we refer to as revenue development, but within the call center, we just call it pickups, because people would call in, but they'd say, my phone number is blah, blah, blah. Their information would come up on the screen along with their address. They'd say, I need a driver. We'd send a driver, that kind of thing. And we ran into a problem for a while where this didn't seem to be taking place in our transactional processing system, because people would call in late in the day and say, where's my driver? You know, we type in the phone number, the profile would come up, and no pickup had been scheduled for that customer. This started happening with increasing frequency, and in the end, where we found the failure to take place was actually in the physical log that was being written to. Okay, we discovered that in the system that we were using, that a hard drive was failing, so that when the information was being written to the hard drive, it was actually being lost. The hard drive was in the process of being of going down. Now, in our system, so the system itself was losing it. It was the actual log that was physically going down. Now, in most companies that deal with mission critical data, you have systems in place that prevent that sort of thing from happening. Usually, you have like a RAID set of hard drives in which the information is physically written to two hard drives at once, so that if one goes down, the other record remains in place. In our situation, we were booking pickups. It was not as critical as that sort of a situation, so we didn't have that in place. This is the guy that first developed these rules for transaction processing. This is Jim Gray. This picture was taken in 2006. Interestingly enough, very, very smart guy. Went through computer science and engineering, I believe, at Berkeley. Was quite a renowned person in computer science. Microsoft dedicated, I think posthumously, their Worldwide Universe. That's not the name of it. Microsoft developed a program. You've seen Google Earth, right? To zoom in different places. Microsoft took the Hubble Space Telescope information and did the same sort of thing, so you can zoom through space based on Hubble data. And they actually dedicated the program to this gentleman. He disappeared in 2008. He was lost at sea. He was heading out, I think the background here is San Francisco Bay. He was heading out to a set of islands off the Pacific coast to actually scatter the ashes of his mother, who had recently passed away, and he disappeared without a trace. Weather was not a factor. He wasn't anywhere near any shipping lanes. No wreckage was ever found. This is a 40-foot boat, kind of hard to disappear. They did underwater searches looking for the boat. They never did find it, which is kind of interesting. But this is the guy that developed these principles. And this is just a diagram of a transaction processing system. But in general, we've all dealt with them in one workplace or another. So management information systems, businesses use, capture, and store data to create information which is used for decision making. And this is a little bit broader in scope than an actual decision making system that we talk about a little bit in the text. One way to have information available is to store it in the form of reports created by an MIS. An MIS typically generates three kinds of reports. Periodic reports, an example of that would be like a monthly financial statement. This time of year, I'm involved in my month-end accounting close, And one of the things that I will do is I will generate a report in a program called Calyx, which is a data mining system that takes data from our Oracle database, which is the backbone, the financial backbone that we use in UPS, and plugs it into spreadsheet cells. And I'll take that and I'll basically take the information for the entire month of January, and I will compare it to exactly the same data for the month of December, and different categories of accounts that have gone up or have gone down significantly in terms of percentage. I'll be asked to explain why the information has gone, why the data has changed. Why are these numbers going up or these numbers going down? If I'm lucky, it's a business reason. If I'm unlucky, it's because I screwed up an accrual the month before. But such as that. I say exception reports. These are error logs, reports that compare actual numbers to statistical tolerances, that kind of thing. And finally, we have what are called demand reports. And demand reports are reports that users ask of the software. Show me this sort of information coming out of my data. Quite often, demand reports, because you tend to want the same kind of data over and over and over again, a lot of systems will have predefined reports. So on a monthly or periodic basis, you just call up those individual reports. A document management system is really a version of an MIS. A document management system enters, tracks, routes, and processes the many documents used in an organization. Documents created electronically, or they can be converted via imaging technology. A DMS can basically be a workflow system by managing, storing, and routing documents. Really, the basis of a DMS is it assumes that most of what the company does can be defined as a series of documents. And a lot of companies are very much like that. In some respects, even the department in which I work is very much like that. A lot of the information that is transferred between sections of my company, there's predefined forms that have to be filled out. And it's those forms which flow between the entities. So a document management system could be of great use in that sort of a system. I believe that Xerox, I won't say they invented this category, but Xerox, the photocopy people, have been into document management in a really, really big way, and have some pretty interesting examples of how you can do routing with documents. So knowledge management. Knowledge is the most difficult form of informational resource to store and share. There are two types of knowledge. First is explicit knowledge, and that is everything that can be written down, stored, and copied. Okay? That's explicit knowledge. That's the knowledge that comes in binders, that comes in databases, that sort of thing. And finally, there's tacit knowledge, which is the know-how that people have through learning and experience. Now, it's certainly not impossible to turn tacit knowledge into explicit knowledge, but it can be difficult. And I'm finding that even now. There's certain tasks that I do and steps that I take that it's just kind of hard to just put it all down in paper in a way that somebody who's never done my job understands it. So knowledge management involves, recognizes, generates, manages, and shares knowledge. Now, expert systems try to capture and store the knowledge of a human expert. Often observation and interview techniques are used to capture how an expert performs work and makes certain decisions. In some respects, these systems are a form of artificial intelligence that tries to provide computer applications that mimic human intelligence. In the rawest form, those of us that have dealt with these sort of talk bots, Rogers uses them a lot here. They're the really annoying, cheery computer voices that ask you questions. You know, I can help you with that. You know, state what you're looking for. You know, and that sort of thing. And They don't work all that bad. Now, they're getting better. They're getting better. In the early days, they were just annoying, and people really, really hated them. I know from my time in customer service that a lot of people realize that if you just press 0 enough times, that eventually the system will throw you at a person. But the interesting thing is that sometimes people get very used to these computerized systems and even start to prefer them to human interaction. When we first, now this example really isn't of an expert system, but a few years back, UPS went to a system whereby when you called in on a phone, the system asked you for your tracking number. Okay? And when we first installed it here in Canada, there were a lot of difficulties because most of our tracking numbers begin with 1Z. Okay? But the system was an American system. So the system expected you to say 1Z, not 1Z. And we used to joke that the company is centered in the South. We used to say that it worked best if you said your tracking number with a Southern accent. But they got a lot of those bugs worked out. And when we first introduced it, people complained all the time. Our customers complained all the time. I hate this, having to say my tracking number and talk to a computer. But after a while, they got used to it and actually got to prefer it to the point that when the system would go down and the calls were automatically routed to a live representative, we'd have people complain about the fact now that they were having to talk to a person. They actually liked the computer system. There are systems, they've been experimenting with systems that mimic human conversation. And they have computer-based systems now that really, they're not smart, they're not human beings, they don't know that much about you, but they are good enough at mimicking human responses that a lot of people, when they talk to the systems, do not know that they are not talking to a real person. They actually are surprised to find out when the tests are run afterwards that they were actually talking to a computer and not a person. So collaborative software, also referred to as groupware, is often used to support tacit knowledge management. And these are the sort of systems that allow people to collaborate on projects and share the knowledge that they have. Decision support systems, we're not going to go into this in great detail. I believe the textbook mentions that the model-driven decision support systems is the most prevalent or popular right now. It focuses on access to and manipulation of a model. But they really don't in the textbook go into a lot of detail and explanation of decision support systems, so we're not going to really deal with it in great detail either. So supply chain management. A supply chain is a system involved in moving a product or service from a supplier to a customer. And supply chain management, SCM, integrates supply and demand management within and also across companies. SCM seeks to optimize the supply chain to create business value and competitive advantage. And supply chain management was, in essence, where ERP systems began. When computers first came on the scene, it was really, really obvious that some of the most difficult tasks which were being completed by human beings could be quite easily done through some sort of a computer system. Okay? In operations, one of the main problems is the creation of production schedules. Okay? I have so much stuff to make. How much and of what kind of stuff do I need to make it out of? How much labor do I need to put into it? When can I expect these things to roll off the assembly line, and in what quantities? These were very quantitative things. They weren't really qualitative decisions. They were mainly quantitative things. And really, it's that section of operations is part of supply chain management. So supply chain management, in some respects, was the place where enterprise resource planning began. Now, ERP, Enterprise Resource Planning, is really not mentioned, I think, enough in the textbook, so we're going to talk a little bit about it. Now, in an Enterprise Resource Planning system, and these are really, really big, really, really expensive systems, important information in an ERP within the enterprise, important information in an enterprise flows among departments without resistance, okay, in an ERP. One of the main reasons for putting ERP together is to avoid the need for middleware. You want the information to go in the enterprise wherever it needs to go without having to stop and get changed into some sort of other kind of information in order to jump from one department to another. Changes to information ripple through the organization, changing related information automatically. Okay, and we'll give you an example of that in a moment. Some of the things that this does is it increases the speed of response within a company. If you're making something simple, change can happen very quickly. But if you're making something as complicated as an airplane or an automobile, it's very, very difficult to make quick changes. ERP allows companies that build complicated things to respond to changes in the macro environment much more quickly. It also tends to decrease costs, primarily by reducing the amount of waste that takes place, both in time, labor, within the company. But of course, obviously, the decreases in costs that are brought about by the efficiencies have to be weighed against the costs of the systems themselves, because these systems tend to be very, very expensive. Also, within an ERP, many decisions are essentially hard-coded as business rules, okay? And that facilitates the increased speed of response. The system knows what it's going to do with the information. It knows how it's going to send the information out, and it does it very, very quickly because those sort of decisions, nobody's sitting and thinking about them. They've already been hard-coded into the system. So here's sort of an example, okay? Let's say we manufacture a car that looks something like this, okay? A gazillion parts, right? A lot of decisions that have to be made about how we're going to bring this car to market in such a way that it's going to be desirable in the market. Let's talk just briefly about something as simple as a change in paint color. So within an ERP environment, the flow of information would work something like this. Marketing determines that platinum black, okay, is the cool sports car color this year. They anticipate that 40% of orders for that sports car are going to be for that color, okay? This information goes into the marketing module of the manufacturer's ERP system. This information goes automatically to the paint team, okay, which is an operations team. It automatically alters production schedules to accommodate the new color. The supply chain module of the ERP system receives the information and automatically notifies the suppliers when and how much platinum black paint is going to be needed. Advertising receives the information and automatically alters planned adverts to reflect the top color. Probably because they have a business rule that says whatever the top color is going to be next year, that's the color we're going to show the car in adverts, okay? Information comes back from the suppliers indicating that this color is 20% more expensive on average than other colors, okay? You may be surprised to discover that all colors are not priced the same. I found out not too long ago, apparently the cheapest color for cars is blue. And the reason for that is what makes a paint blue is the element cobalt, and apparently there's lots of it. It's cheap, okay? But certain other colors include much more expensive components, and you can actually be in a situation where you pay more for a car simply because of the color. So information comes back from the supplier indicating that this color is 20% more expensive on average than the other colors. Pricing receives this information and automatically changes the manufacturer's suggested retail price of the cars so painted. Okay? So I think you can see that in an ERP system, especially when we're doing manufacturing, that this information can travel very, very quickly and can allow a company to be a potent competitor in its particular market. We'll mention, though, I didn't devote a slide to this, but should mention that these sort of integrated systems, because they are so broad and so all-encompassing, tend to be very, very expensive. And there's a cost-benefit analysis when you want to put an ERP system in. So this is the historical background of ERP. It began with something that was called MRP, Material Resource Planning, which is sort of a branch of supply chain management. It was the first large-scale application of computers to production, MRP was, and it calculated the materials and sub-assemblies necessary to meet production quotas and deadlines. Okay? It worked backwards from what was called a BOM, a bill of materials for a given product. For instance, if you're building this particular aircraft, there would have been, when they were building that particular aircraft, a physical list on paper that defined the bill of materials. Everything that was needed to go into this particular airplane. So with MRP, you started with the bill of materials, and that bill of materials, you use computers to facilitate the rational decisions about what supplies to order and when to create the production schedule for that particular aircraft. Now, these systems, the MRP systems, operated on the mainframes of the 60s, and they gave large companies an advantage that complemented such things as economies of scale. Okay? It was expanded to such related activities as writing production schedules, calculating costs, and integrating sales forecasts in about the 70s. And the expanded form became known as MRP 2. The first official implementation of MRP involved the J.I. Case company, which manufactured tractors, and IBM. I believe that this is the emblem of the Chase company. This actually, I believe, is the front of one of their early tractors, which was a steam-driven arrangement. You're actually looking at the front of a steam boiler. Now, some ERP timelines. And I mention these because these are names you're going to bump into, not merely in class, but if you go on to Career Beacon and look at different business-related jobs right now, you're going to see some of these names pop up, like SAP and PeopleSoft and that kind of thing. Probably the first modern implementation of enterprise resource planning. In 1972, 5 former IBM programmers started a company called SAP in Germany, which stood for Systems, Applications, and Products. And their business model at the time was a standardized rather than a completely customized software solution. Now that might seem strange today when virtually all software is, in some sense, off the shelf and then customized for a user. But in 1972, pretty much all the companies that were using software in the business world were using software that was specifically written just for them. Okay? So they were introducing large-scale integration, software integration that was, the bones would suit pretty much any company, and then you customized it to fit around the edges. In 1976, MRP was the dominant force in organizing and manufacturing processes. In 1977, Larry Ellison started Oracle. Larry Ellison began, and Oracle actually was the name, kind of a scary guy, Larry. He worked for the CIA. And actually the project that he was working on for the CIA, I believe it was codenamed Oracle. And when his contract ended, he took the knowledge that he had learned in that particular project and started to apply it in the business world and kept the name. The start of Oracle in '77 is important because of the huge size of the company today and its influence in ERP systems. In 1978, J.D. Edwards, which was another ERP system, was founded in Denver, and the name is a portmanteau of the 3 founders' names, Jack, Dan, and Ed. So there actually is no one called J.D. Edwards. J.D. Edwards was just a name made up of their three names. And their basic background was accounting. Their focus at the time was on IBM mini computers, especially the AS400. And the 52% annual growth that this company enjoyed in this market was probably largely determined by their decision to use the AS400 as the backbone system. The AS400 is now it's now a legacy system. Not a lot of company. I'm pretty sure that IBM has or is in the process of getting rid of all of the AS400 systems that are out there. People tend to really hang on to their technology, especially if it works. And it's one of those things you almost have to pry it out of their cold, dead fingers before they'll give up on a particular system. But because they had chosen the AS400 system as their platform, and the AS400 system became very, very popular, it created tremendous annual growth. In '87, PeopleSoft was founded in California, and they moved into enterprise resource planning from the HRM modules, if you will. And pretty much a lot of these systems started out as what we will define later as enterprise systems that started out within a particular section of the company or business, and then they sort of moved out to the rest of the functions of the business all at once. But often these systems, a lot of these systems sort of retain the flavor, if you will, of whatever the base system was. J.D. Edwards started with accounting. PeopleSoft started in human resource management. And because human resource management is by its nature more human than mechanical, it was often described as the easiest and most intuitive to learn system. And PeopleSoft pops up a lot on CareerBeacon as one of the nice to have lists of information at the bottom of the information about the job. It's an asset if you've worked with PeopleSoft before, that kind of thing. Now, in 2003, PeopleSoft bought J.D. Edwards in a friendly takeover, and the reason that they did this is they were trying to create a company too big for Oracle to take over. So this was a friendly takeover. However, a year later, in a hostile takeover, Oracle swallowed PeopleSoft, and along with it, J.D. Edwards, in one gulp. They paid, $10.3 billion in that particular deal, and this was part of a 50-company shopping spree that Oracle went on. The latest acquisition was Sun Microsystems that they bought for $9 billion last year. If you don't know who Sun Microsystems is, they are the creators of Java. That's probably where it would touch most of us most dramatically. The merger and acquisition meltdown in this industry is making regulatory approval in both the U.S. and the European Economic Community a bit of a hurdle. Some of the questions that exist right now. Now, Oracle basically has turned this particular industry on its head. What was once SAP versus a very fragmented competition is now mainly a two-horse race, with SAP actually being the underdog in terms of size of company. While this was all going on, Microsoft acquired a company called Great Plains and then Navivision for a couple of billion, and Microsoft Business Solutions became a little bit more of an ERP system as part of all of this. There's quite a few smaller vendors around, and open source ERP is now entering the field. SAP is still smaller than Oracle as a company, but it's still number one in market share. Neither company is wounded, but Oracle came out of the recession slightly better than SAP. SAP has been aligning itself with Microsoft since it lacks a database engine of its own. Most of these systems are designed so that whatever big, robust database your company uses, you can use that backbone to run the ERP system. So SAP could be run on an Oracle database, it could be run on an IBM DB2 database, that kind of thing. But it doesn't make a whole lot of sense to have an Oracle database system in your company and then ignore the Oracle ERP offerings and go with SAP. So obviously this made SAP a little bit nervous, and they've been aligning themselves with Microsoft in sort of a strategic commercial alliance to provide the backbones necessary to run the software. Oracle offers more applications than SAP through its buying spree, some of them best in class. For instance, Siebel is probably the best customer resource module in existence, and it's now under the Oracle umbrella. However, Oracle is now a truly humongous company, and there are lots of instances where companies have gone on these sort of buying sprees and become huge and huge and huge and huge, so huge that they eventually kind of collapse under their own weight. Some people believe that essentially that's what happened to Sun Microsystems, which Oracle recently bought out. Microsoft is the vendor of choice ERP systems for SMB, small and medium-sized business, as opposed to the really, really big players. And a couple of other smaller companies. Infocore is usually considered number 3. Another company called Epicor are offering lower costs to serve, even though they're not as well known in the market. So enterprise systems that support the value chain. Enterprise systems are large-scale applications that support a business unit or function. They're another way that an organization might apply IT to its value chain. Some of the differences here, ERP versus enterprise systems. ERP offers efficiencies across the entire enterprise, but their scope involves huge costs and corresponding risks, whereas enterprise systems offer efficiencies within the value chain, functions, and the scope is smaller, and as a result, so are the costs and the risks that are associated with the implementation. As mentioned before, providers of enterprise systems sometimes grow these systems into ERP systems, and often these ERP systems exhibit best-in-class performance in those modules which form the root from which the rest of the tree grew. Value chain systems, enterprise systems support the value chain. Once again, every section of the value chain essentially has enterprise systems that are devoted to it. Some of the most notable: customer relationship management provides tools to better service customers, while admin and finance systems are aimed at automating and optimizing administrative processes to reduce costs and ensure efficiency. HRM systems, as well as technology development, support value-creating activities. And raw material is often through modules that are connected to procurement. Now, and with this we'll close. Software as a service, SAS. This is completely different from what we've been looking at before, but it's in the chapter and it's worth mentioning. There are two fairly new models of getting software into the hands of users, and both of these are essentially web enabled. In software as a service, companies essentially rent software that's being offered to them usually through a web client browser. Utility computing services is a related idea, provides on-demand software hosted on servers which can be accessed from anywhere. Also, software can be provided to an organization through an application service provider. And an ASP is an online technology company that develops and delivers software tools over the internet. Now, the pricing model tends to be a little bit different under SaaS. Usually the pricing model is per use or per user, whereas an ASP usually introduces a flat fee or subscription. They differ a little bit in the ability to be customized. ASPs offer more ability to be customized and control over the system. Under SAS, usually you have no control at all over the system. You might have some if you're dealing with an ASP. And finally, enterprise risk management. With this, I'll close. We're not going to talk a lot about ERP. They talked quite a bit about it in the text. We're probably not going to go into it in great detail in this particular course. ERM is affected by entities, stakeholders applied strategically across the enterprise. Basically, the idea that you see in the textbook is it's important to understand that technology has an influence on protecting the enterprise. Compliance and control frameworks and standards for IT. The reason I've included this slide is just I want you to understand I don't really need you to know this. Okay? The textbook lists all of this stuff and all of these patterns. Obviously, as far as the textbook authors, somebody is right into this, but these are all more or less in a state of flux, so I'm not really worried right now about you having an in-depth knowledge of compliance and control. By my watch, we have 5 minutes left, which was just long enough to